Hi out there. Okay, so today we're talking about moonquakes. And you know, when you think about moonquakes, you wonder, well, what's going on up there on the moon? Does the moon have, does the ground shake on the moon just like it does on Earth? Well, scientists found out that yes, it does. And so let's talk a little bit about what it's like on the moon and kind of what it's like on Earth. And you're going to use your space bar. I've got some cards here that can help us think about what is it really like on the moon? Does the Earth have some things that are the same as the moon, like earthquakes, moonquakes? Does the ground shake on the moon as well as the Earth? Yes, it does. But there's some other things that are the same on Earth that is on the moon too. So let's kind of sort that out. So let's do some thinking. You can use your space bar and tell me what you think, yes or no, and then we'll put the cards in appropriate places. So I'm thinking, we have a lot of weather on Earth because of our atmosphere and clouds and things. Do you think the moon has lightning? What do you think? The moon has no atmosphere.
No.
You're right. The moon has no lightning. So it's only on Earth. So I'm going to stick my card onto my Earth ball here. The Earth is the only one that has lightning. Okay, so how about volcanoes? Do you think the moon has volcanoes?
No.
You're
Moon
right.
Does not have volcanoes.
It doesn't. You're right. You are right about that. Maybe a long time ago when it was first formed, when it broke away from Earth, it did, but it doesn't right now. It has no volcano. So Earth is the only one that has a volcano. Oh, and here's what we're talking about today. Quakes. Shaking the ground. Whoops, my card's stuck together. Uh-oh. Quakes. So that's an easy one. Yep, earthquakes and moonquakes. So we're going to put that card right up here because the moon has quakes. Okay. Oh, tornadoes. What do you think about tornadoes? Yes or no? Just on Earth. You're right about that too. So we're going to put that on the Earth ball. Yep. Oops. Some of my stuff is falling off my Earth ball. Okay. Oh. Now on Earth, we wake up in the morning and it's light, and then the sun sets and it's nighttime. Does the moon have night and day as well as the Earth? Guess what? Wow, it does. It has night and day on the moon. Yep, we see the day side a lot, but yep, it has night and day. Oh, here's something we have on Earth because we have so much oxygen and atmosphere and things like that. Fire. What do you think? Right, only on Earth because the moon doesn't have any atmosphere. So I'm going to put that on our Earth. My ball is getting pretty big. Oh my goodness. Impact craters. Craters. What do you think? Do you think the Earth has craters? Do you think the moon has craters? Yep, the moon definitely has craters. And actually, so does the Earth, has a few, but not as many as the moon. So we're going to put that one there. And, oh, do you think it ever rains on the moon? Yep, never the moon. That's right, because there's no atmosphere, there's no clouds, so it can't rain on the moon right now. Okay. Oh, and the last card I have is a rock slide. Actually, there is. There's gravity on the moon and there's gravity on Earth. So in both places, there's rock slides. Wherever there's gravity, there can be, there might be some loose rocks. There's rock slides on the moon. Wow. So we're going to talk about the main one today is quakes. There are quakes on Earth and there's quakes on the moon. And when they happen on Earth, we call them earthquakes. And when they happen on the moon, we call them moonquakes. And that's pretty simple. That's the easiest thing to remember. So why do we have earthquakes on Earth? We're going to take a look about that. the surface of the moon is way, way different from the surface of Earth. When you take a look at my Earth ball here, there's lots of water and things, and there's no water on the moon. But why does Earth have earthquakes? So we're going to take a look at a couple of things to find out why we have earthquakes. And I'm going to change the camera so you can see my puzzle on the table. Okay, there is a picture of Earth. And Earth has a crust. The surface of the Earth is kind of always moving. That's kind of weird because when you stand on the ground and stand really still, you don't really feel it moving, but it is. And it has different pieces of the crust that come together, and they're always moving and kind of rubbing past each other. So I'm going to take these apart so you can see it a little bit better. And they're called plates. So let's build the Earth back together. Okay, so here's a plate, a big piece of the Earth's crust, and there happens to be a lot of ocean over that one. And here's another piece of the Earth's crust, and that has a little piece of Antarctica and a little piece of South America. And then here's another plate, and these kind of move a little bit. There's the African plate, and here's where we live in North America, and that is a great big chunk of Earth crust. These are huge pieces of Earth crust that makes up the whole world. And on this piece, there's a lot of them put together, but they're always big pieces of the Earth crust, and they fit together and they rub past each other. And I'm going to take and go back to the FaceTime camera. What are these plates moving on or across? Now, last week we cut a Play-Doh ball. We made layers. We were talking about asteroids, and we were talking about how some asteroids had layers. Well, the Earth does too. So I made another one, and I'm going to cut it in half so you can see what I'm smushing my Play-Doh Earth. Oh dear. But remember how when you opened up your asteroid ball last week, there was different layers inside, and different layers inside Earth. This one is really hot and molten rock. That's the core. And then there's a mantle around it, and there's the crust. And so the crust is solid, but the molten rock is a liquid. And so the crust kind of floats around in these plates all over the top of the mantle and the core. So they can move. They can move. Everything is always moving. So it's kind of, I made another ball, and I made one from the moon, because the moon doesn't have any plates or big pieces of crust floating around on a core. It does have a core, but that core cooled off a long, long time ago. Whoops. And it's a lot smaller than Earth's, and it's pretty solid. So the moon is solid all the way through, even though it does have a core. It's just one big solid ball. So its surface can't float around. Its crust can't float around on the liquid that's in the inside. It's just solid, solid, solid. Boom. So, wow. All right. So we're going to take a look at, and you can do this with me if you brought some of the supplies that were mentioned. And we're going to make a shaker table to see how these plates in my plate puzzle kind of rub past each other. And it's kind of fun to do because we get to play with Legos or blocks and some rubber bands. And I brought a couple of books. So we're going to make some plates that rub together to show how earthquakes happen on Earth. So the first thing you want to do is get your books, if you have a couple of books. And if they're about the same size, that's good. I had some old encyclopedias and got to do something with those. And I've got some rubber bands, and I've got some little balls that were all the same size. And I have over here, we'll get out the Legos too, because we're going to try to make a Lego building crash down. So let's start by making our book and our shaker table. So what I want you to do is hold your books together and then take a rubber band and wrap it around, whoops, one side like that to hold your books together. Whoops, one edge, okay? And then on the other side, I put another one right across. Okay, so they're held together, but they can still move. See that? So I have a couple more rubber bands that I might use. Oops, I lost one. It'll help hold it stronger. But if you only have 2 rubber bands, that's fine. So now these will move past each other. So now we're going to use the little balls because we want to really make this shaker table. So I'm going to hold up my encyclopedia and I put that ball under there. Can you see? It's in there. And I'm going to put all 4 of my little balls in the center, kind of under between the 2 books. Okay, like that. Pretty good. All right, good. So now watch what happens. I'm going to hold it up a little bit. Whoa, my shaker table moves. So let's shake something. Let's try to make a Lego building fall down. Now I made this ahead of time because I had time, but I had a little base. And what I'm going to do is I'm going to take my tape and tape that base to the book. And if you don't have a base, that's all right. Because I don't want it to fall off, but we can still do it even if we don't tape it. Because it'll show us just how shaky the plates or the shaker table is, which is simulating the Earth's crust. So I taped my base down, and now I'm going to start to build my Lego tower, my Lego skyscraper. And do you think what's going to happen when this table starts to shake back and forth, when the plates start to move? The plates of the Earth's crust start to move. What's going to happen to my Lego tower? I don't know. So I'm going to shake it now, back and forth. Let's see. Uh-oh. Oh, no. It fell right down and it kind of, whoa, broke in half. I'm going to do that again. I didn't have to shake that very much to make it crash. So hopefully you can shake yours. Whoa. Okay, I'm shaking mine pretty good and it's wiggling, it's wiggling, it's, whoa, there it goes. So, and if you have anything else, you could probably even use some other kind of blocks too to see what happens. I have some dominoes, so I don't know what other color kind of blocks you have. So, I'm going to take my Lego base off and just see if I can knock over some dominoes. So you can try this again and again now that you've got your shaker table built, and you can see what kind of building you might want to build with other kind of blocks or different ways to arrange your Legos to see what you can knock down. Now I'm stacking some dominoes here, but you can stack some other blocks or even just more Legos. And let's see what I can do about this. Whoa! Even my little tower fell down. So that's kind of a fun kind of thing to see what happens in an earthquake. We're kind of lucky here in Michigan. We don't feel earthquakes very much because we're not right on the edge of a plate like California or something like that. So there we go. So there is our shaker table. And I'm going to put that down and keep that out of the way because I want to talk about the moon again. All right. I have a little squishy moon ball, actually. Put my shaker table down on the floor. I have a squishy moon ball. So the moon actually has earthquakes without plates. Like we said before, there's the moon and the core. Whoops. I messed up. The core, it's all solid, so there's no plates to squish by each other on the moon. It's all solid. So how does the moon have earthquakes? Well, there's 4 different kinds of moonquakes. One of them I call the gravity tug, and that's because of gravity. Any big planet, well, Earth is kind of a small planet, but a big planet has a gravity tug or attracts a smaller one. That's how come the moon stays in orbit around Earth, because Earth's gravity is pulling on the moon and it pulls it right into kind of a circle. But it's not a perfect circle. Sometimes the moon is a little closer to Earth. Sometimes in its orbit, it's a little farther away from Earth. And so sometimes the Earth's gravity is a little stronger on the moon. And sometimes the Earth's gravity is a little bit weaker on the moon. So when it's the closest to the moon, the gravity on Earth pulls on the moon and the moon stretches to one side. I mean, I'm squishing my moon, so it's all stretching towards the Earth right now. You wouldn't see it, but the moon surface can feel it. It's kind of like stretching a balloon. So if you have a balloon to play with too, you can squeeze it and see if you can make it go all to one side. That's kind of what happens. Gravity pulls on the moon a little bit when it gets close to Earth, and it stretches the surface of the Earth. Now, I have another balloon here. When we talk about stretching the surface, watch this. If you blow up your balloon, the surface of the balloon is going to stretch. So that's kind of what's happening. And it gets bigger and bigger and bigger, and the surface stretches and stretches. So that's what we're talking about. And the moon, as it's close to Earth, it stretches the surface towards there, and it's just rock. It's not stretchy like a balloon. It's gonna crack up, and when it does, it shakes a little. So that's one of the causes of moonquakes. It's the gravity tug. The Earth hug and the gravity tug. Yep. So another reason that the moon has earthquakes is because of general cooling. Remember I said with this moon, how maybe a long time ago, millions of years, there was a little bit of a core that was liquid, but it cooled and it cooled and it cooled and it cooled, and now it's all solid and no liquid, all just totally solid. And so as things cool, they shrink. So I have something fun to look at. I got a big fat blueberry and I got a little shriveled up blueberry. And if I hold them in my hand, you can see the difference. So it's kind of like what is happening to the moon over millions and millions of years. It's going from something slightly bigger to something a little smaller. And as it goes smaller, the surface shrivels up and shrinks, just like my big fat blueberry to my little skinny blueberry. And as the surface shrinks, it develops cracks. So if you could do this with a raisin too. Take a look at a raisin, and it's got lots of little cracks and bumps and shrivels. And over time, it shrivels even more. That causes the surface to crack and shake. The blueberry effect or raisin effect. So it's cooling slowly and slowly and slowly. Okay, so there's another, that was number 2. This is number 3. Here's another reason why the moon has earthquakes or moonquakes. Quakes. Asteroids. Remember asteroids from last week? They're big. They cause craters. They hit the surface of the moon. Kablam! And when they do, they shake the ground. So I'm going to put a little bit of water in I have a pan here, and I have some water. And let's see if we can actually see the shake. Like if we had some water, this would actually be, in this case, the water is going to be substitute for the ground. There used to be a movie called Jurassic Park, and when the big fat dinosaur walked by, the water shaked and rippled. So I'm going to turn this on to my tabletop camera, and let's see if we can actually see some waves. Oops, there we go. Okay. So can you see kind of the waves? All right, so now I'm going to take my big asteroid and pretend that it hit the moon's surface right over here and see what it does to the pan of water. See if you can see some waves. 1, 2, 3, bam! Holy cow! Did you see the waves that the impact of the asteroid on the moon's surface had? Let's do that again. Kablam! Boom! Oh, I love it. That's pretty cool. So that's what an asteroid can do to the surface of the moon when it hits the surface of the moon. Boom! There's no water on the moon, but all of the surface kind of shakes and waves. So I'm coming back to the FaceTime camera here because I have a Slinky to show you. Whoops, wait a minute. I lost my, there we go. Because I want to talk about waves. You saw the waves on the surface of the water? Well, I also have a Slinky, and I don't know if you have one too, but we can make some waves with this Slinky. So if I hold it over here and shake it, I can feel, oh, you have a Slinky, good. So you can put it down on your table if you want, and you can stretch it, or if your mom is by there, you can have her hold one end, and then you can kind of pinch it. Did you see the wave go across the Slinky when I pinched it and then I let it go? Did you see it? You can pinch it and let it go. That is called a P wave or a primary wave. There's another wave that you can do with this, and I'm sure you've had fun playing with Slinkies. It's the secondary wave or the S wave. And it's kind of like, can you make the Slinky stretch and make a big wave along the end? Yep. And here's something to try if you have a partner. You can have a partner hold one end, and you can hold the other end, and then they can pinch it on one and see how long it takes for that wave to travel from one end to the other. You don't feel it right away. It takes a while to travel down to the other end. So you can play with that and have some fun. But that's why what happens when you take a great big old asteroid and hit the surface of the moon, you're causing waves to travel across the surface of the moon. And that makes moonquakes. That makes the third kind of moonquake. So now, aha, there is also a day and night cooling effect that can, remember how we were saying that the moon is cooling off all the time? But because there is day and night on the moon, during the daytime, the sun is just hitting that old moon, and some of the temperatures on the moon can get really, really hot. Even though it's up there in space, the sun is just hitting that, and it's getting really, really hot. But then night happens, and there's no atmosphere on the moon, so all of that heat goes out into space, and it gets really, really cold. So I don't know if you have this with you today, but if you do, I said probably ketchup bottle, or I have a 2-liter bottle today. What I'm going to do is I'm going to put some warm water in here. So if you have some water, like the hottest tap water you can get, you can put it inside your ketchup bottle or your 2-liter bottle. And I have some. What did I do with it? Here it is. I'm going to do that to my 2-liter bottle. Oh, wait. I'm going to put a tray down because I'm messy. Messy, 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 messy. And I'm going to pour some hot or warm, really, really warm water in your ketchup bottle or your 2-liter bottle. Uh-oh, yeah, I'm messy. It's a good thing I have a tray underneath this, because I couldn't get it all in here. Okay, so, and I think I had a little bit. I don't know how much I got. I spilled a lot of it on my tray. And then I have a lid that I'm going to put on it. And I'm going to wait. Can you see the steam inside my bottle? Yeah. It's getting all hot in there. And then, well, you can do this a couple ways. We're going to cool it down. So now let's pretend this is the moon's surface. The surface of the bottle is the moon's surface, and it's all hot because the sun is shining on it. And so now we're going to cool it down because it's turning to night. So there's a couple ways you can do it. You can get some cold water and hold it under the cold water faucet. Or since I'm not near a faucet, I have some ice. Or you can take it outside in the snow. But I have some ice. And let's see what's going to happen to the surface of the moon when I try to cool it down and pretend it's night. What is going to happen? I'm going to roll it around on my ice and try to cool it down. And if you roll yours under a cold water faucet, what is going to start to happen to your bottle? Mine is taking a long time. I don't know why, because I did this last night and it started to happen immediately. Today, but maybe it will. Maybe I should come back to it in a little bit. Uh-oh, my ice cubes are falling out. Oh no. Put those back in there. Well, my ice cubes are definitely melting, I'll tell you that. I'm gonna have to put this to the side and come back and see if it happens later. But what happens is once you start to cool down that bottle, it shrinks and it cracks. So the shrinking and the cracking of the moon's surface causes more earthquakes or more moonquakes. Oh, I had a little teeny one. I don't know if you heard that, but I heard a little pop. Yep, it's shrinking just a little bit. Whoa. Anyway, you can play with that later. Yeah. Oh, yeah. So if I don't know if you can see it, but my moon surface just had a little shrink. It's shrinking in on itself just a little bit more. And I think if I held this over a couple more minutes, it would shrink even more. It's sucking on itself. So I'm going to put this down because we have a couple more things to do. So how do scientists know that there actually was moonquakes? Well, a long time ago, when they went to the moon back in, I think, 1969, they left an instrument called a seismograph or seismometer. And so we're gonna make one of those together to show you kind of one of the features and how they work. So today, if you brought about 6 paper cups, a little bit of Play-Doh, a pencil with no eraser on it. See how it's got a flat end? And, you know, I have a little cardboard base, but you could do it right on the top of your table if you want. So we're going to build a seismometer. And the first thing we're going to do is take this pencil and my Play-Doh and stick the pencil right into the Play-Doh so that that can stick straight up like that. And so I'm going to try to put a little ball on there to see if it will. Oops, my ping pong ball won't. Hold on. There. All right. So now take some cups and put it all the way around the Play-Doh, probably about 6 of them. Ta-da, just like that. And now what we're going to try to do is see one of the things that a seismometer or seismograph measures is which direction the quake happened from. Where is it coming from? So I'm going to put a little ball on the top of my pencil and I'm going to tap the table. This is not happening. I'm going to tap the table and see which direction it came from. I can't get my pencil to stand up straight to balance my ball. That's the hard part. Okay, here we go. I'm balancing a ball, top of my pencil. Maybe I need a fatter pencil. Okay. Anyway, we're trying to catch the ball in a cup, but I can't get my ball to stay. Okay. Anyway, if I tap over here and make an earthquake, the ball is going to fall into the cup closest to where I tapped. Ah, okay. There. I had to hold it. So you can play with that a little bit. Let me try a ping pong ball. Maybe that ping pong ball will stay up there again. So wherever you tap, should go that way. So I'm holding it just very slightly. Yep, there we go. Now what happens if I hold it very slightly over here? Whoops, wait a minute. Gotta make sure it's, yep. So whichever direction you tap, you can tell which direction the vibration or the waves came from. So that's a little bit of a seismometer there. Ta-da! So we have one more thing to do before we're done today. And it's just kind of a fun thing to do. I have some wafer cookies. And oh wait, I have two more things. Oh my goodness, I have so much stuff here. I forgot all about it. So when you get an earthquake going really, really strongly, something happens to the ground. It almost becomes liquid. So if you have a pan and if you have some sand and a little bit of water, where's my water? Oh, here's my water. We're going to see how we can kind of make some ground be so, oh look, my bottle crushed, finally crushed. Anyway, so we're going to put a little bit of liquid in the pan, and then we're going to cover it with sand so it looks really solid, and then we're going to shake it to watch it become liquid. Okay, so here's a whole bunch of sand that I have, and I'm going to pour it in my pan, spread it around, and that looks pretty solid, don't you think? I mean, it sucked up a little bit of the water, but there we go. Playing with my sandbox. Okay, so now I'm going to shake and watch. Oh, a whole bunch of water came to the surface that time I saw it. So you can try this at home. Let it all down so you can't see the water, and then shake it. And it makes the soil almost turn liquid. And if you want to see what would happen if a house was sitting on top of that, if you had a Kleenex box, you can set, and I have a rock to weight it down. And I'm going to plant my house. Let's see what happens to my house if the ground underneath it is shaking back and forth. My ground is moving, and my house is starting to sink down into the sand. I don't know if you can see that, but you can try that too. You could even try that instead of a Kleenex box if you had maybe a Lego tower. You could try that too. Try some experiments and see what happens. Okay, plant my Lego towers together and shake it. Whoops, that's not going to work. I'm going to do it this way. Anyway, watch your buildings sink down into the soil because the soil is turning almost liquid because of that earthquake. Yeah, I'm sinking my Lego blocks down inside. I don't know if you can see that. There we go. Anyway, so that's kind of a fun thing to try out. And the last thing is even more fun because it involves food that I can eat later. Let's build. If you have a pan of Jello, I have one that's left over from last week. I didn't eat it. And I have a pan of Jello, and I have some wafer cookies. And I'm going to try to build a house or a structure that will, oh, look at how it wiggles. Can you see that wiggling? If I do that, put my wafer cookies on the top. So I'm going to try to build something that will stay. So what I'm doing right now is I'm taking and lining up my wafer cookies one direction, and then I'm thinking to make it stronger, maybe I'll go crisscross and then back over the top. So this is the ground, and ground shaking is one of the reasons scientists measure it on the moon, because if they go back to the moon, they don't want to build a structure that would fall down in a moonquake. So I've got a pretty good tower here. What do you think is going to happen when I get all my wafer cookies crisscrossed over the top? Whoa. If the ground is wiggling, so will my building. I got two more. Dun, da, da, da. All right. So now it's time to wiggle the pan of Jello. Uh-oh. I think I can predict. Can you predict what's going to happen to my wafer cookies? Because Jello is very wiggly. And so if that was the ground that I was going to, oh no, if I was going to have an earthquake, oh no, I just lost the top of my wafer cookies. Oh no, it did. It fell. Let's see if I built my wafer cookies on something more solid. I've got a solid pan. I'm gonna see if I could probably something more solid. Let's see if that would work. I don't know, but you can try out some things just to see what happens in an earthquake. I'm just gonna do a few of these, and we are all done with our experiments for today. Let's see. I got a solid pan, and I'm going to tighten my wafer cookies up. And I'm going to shake it. Staying together a little better. Just a little, but they did fall. So you can see what happens in an earthquake. And have fun today playing with your blocks and see if you can build something that won't fall over as easy. So thanks for doing all those experiments with me today, and hope you learned a little bit about moonquakes. I saw something I had never ever seen before. And here's where you get to make a choice. Was it a giant Tyrannosaurus Rex? And I'm just gonna stick some pie cones in my box, and then the fun starts. I just start rolling them around. The air rushing out of the balloon is going to push that balloon up. So let's see what happens. All right, 1, 2, 3. Oh, wow. So that's how rockets kind of work. We are going to build 2 different kinds of rockets today. The cork on as fast as you can, set it down, and wait. Woo! All right.